Okay, hello geometry students. How everyone doing? Okay, so we're getting near the end of our area lesson. We're going to have a review on Thursday. Wait. We're going to have a review on Friday and a quiz on Monday. So you can review all weekend. So let's do this here. Okay, so what am I going to do? Okay, I have the group practice. I'm going to tell you there's going to be a bonus. I'm going to go over the exit ticket. So you don't have to do the exit ticket alone. But it's an important one because there's going to be a question like it on the quiz. So let's look at this one, though, because I still want to talk about these regular polygons. Okay, so let's imagine this situation. Okay, so they say, what is the area of a regular pentagon with 4-inch sides? Round your answer to the nearest square inch. Well, if you remember from yesterday, area of a regular polygon is equal 1/2 A times P. A is our apothem, okay, and P is the perimeter. And if you really want to remember, the perimeter is equal to the number of sides times the measure of that side. In our case, it's 4. Side. So it's the number of sides times the side length. Okay, so we actually have the perimeter. That's not bad. It says 4-inch sides. Okay, so that means this side is 4 inches, 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 this side is 4 inches. Remember, you can do it the long way and do 4 plus 4 plus 4 plus 4 plus 4. I prefer saying a pentagon has 5 sides, 1, 2, 3, 4, 5, times each side length is 4, 5 times 4. The perimeter of my pentagon here is 20. Okay, now the question is the apothem. Now the apothem goes from the center. Okay, let's do this real quick here. Gotta find the center. Now the center that's about as close as I think we have to get because I'm just drawing it to give us a reference point. I'm not drawing it to be like, okay, well, this is, exactly the center. We're going to look at what it would look like. We're going to imagine what it would look like. Hopefully I'm pretty close to what the center of this pentagon is, but it doesn't have to be perfect. So what I'm doing now is looking at this, and I want us to look at this. So if you can't print it up, and it's hard to draw a regular pentagon, try the best you can. Okay? But we're not really looking at the pentagon. I'm looking at another shape. And that other shape I'm going to look at is the triangles. Now, the one thing, if you remember from the apothem, is it starts out from the center, and what it does is it goes down and it meets the side at a right angle. Okay, so I have to find this length. This is my A. That's all the information I have. Well, it seems like that. Well, it's not completely true. We do have more information. This angle is equal to this angle, is equal to this angle, is equal to this angle, is equal to this angle. These add up to 360 degrees. All 5 of these add up to 360 degrees. So that means 360 degrees divided by 5 will give me the answer of all these angles. So let's do that. Okay, it's not bad. Clear. 360 divided by 5 is 72. So, all right, okay, 72. So all these little angles here are 72, 72, 72, 72, and this is 72 too. But if you remember, the apothem, since it goes from here and perfectly cuts this in half, which also means this is 2 over here, this little part, and it also cuts the angle perfectly in half. That means this whole angle is 72, but half of that angle, it's an angle bisector, 72 divided by 2 is 36. Okay. Still haven't found the apothem, but we have a couple of interesting things. I have a triangle now. Okay? I want us to look at this triangle. Okay, this greenish triangle, I'm trying to highlight it as much as possible. Now imagine this. So we got a right triangle here. We got to remember one thing. So, Tawa, which means we're using either the Desmos scientific calculator, okay? Google search it, Desmos scientific calculator, or we can use my calculator, regular calculator, but we need something with sine, cosine, and tangent, and I have to make something sure first. I have to make sure I'm in degrees, okay, which I am. I don't want to be in radians. That I don't want. I want it to be in degrees. I make sure with any other calculator you use, you're always in degrees, not radians, because we have 36 is in degrees. Okay, so 72, 72, 72, 72. I mean, this is really 36 and 36 adds up to 72. So I look at this. This, if I'm doing SOHCAHTOA, would be my theta. This 2 over here is my opposite. What I want to find is my apothem, which is apothem, excuse me, which is right here. That's A. And that is also happens to be, well, this is the hypotenuse. I'm not going to look at that. That doesn't really, we don't need the radius of this. That's not important. The apothem is apothem. I just keep saying it wrong. Apothem is the number we're looking for, that A. So what has, and that is adjacent. So I have my opposite, my hypotenuse, my adjacent, but the only two numbers that count to me are adjacent and opposite. Well, which one has adjacent and opposite? Tangent. Opposite and adjacent. So that I know, tan of theta equals opposite over adjacent. Well, theta is 36. From there, opposite is 2 from here, and adjacent is A. All right, it's one of my least favorite trig problems when the variable's on the bottom. I don't mind with the variables here, I don't mind the variables here. When it's there, I always get upset. Okay, so, because this is what we have to do. Okay, so I'm going to start over here. All right, so we have tan of 36 equals 2 over A. Okay, it doesn't look like that bad numbers, but I got to do some algebra first. Okay, I got to get the A over here first, A. So I multiply both sides by A. So now I have, my next step, I have A tan of 36 equals 2. Now, tan, remember, is just a number. So I can divide both sides by 36. These two tans will cross out. And I will have A equals 2 over tan 36. Now this should finally, after all this work, you're probably exhausted at this point, we still have to do the formula. We still have to put the A in the formula all the way up here. But we'll get that in about 2 seconds. Calculator. Clear this out. What we have to do is 2 divided by tan 36. The answer I get is 2.75. This here, our adjacent, our A, what we wanted all along is 2.75. We move up here. Okay, back to the original problem. A equals 1/2. Now we have our A, our apothem. From down here is 2.75 times the perimeter, which we figured out all the way 5 years ago, is over here, 20. I'm going to put this in my calculator. I'm not going to go crazy with trying to do this in my head. Actually, I can see what the answer is already, but I'll just pretend I don't know, and we can do this else. So it's really, real quick in the calculator. 1 divided by 2, 2.75, 20. Enter, 27.5. So the area of our pentagon, after all that, it's in inches. 27.5 inches squared. Oh my God, what a brain buster that one was. My head even hurts. Okay, we'll be back.